Hey gang, quick video to help you out in case you need it for Tuesday, April 7th, about working with fractions. Again, this is another one of those things where at the end of the day, you know, on a typical test or a homework assignment or something, you're probably never going to be denied use of a calculator, but that doesn't mean that you will not need to know how to work with fractions, by hand. You're gonna need to know how to add fractions and subtract fractions and all that kind of stuff, and multiply fractions. You have to know the rules down the road, in situations where calculators would actually not even be able to bail you out even if you had them right in your hand. So first of all, if you had a fraction like, I don't know, 6 over, it's really hard to draw straight lines with a mouse. If you, oh gosh, 6 over 8, I don't know, 6 over 8, okay? Hopefully that's not literally one of your problems, but and you wanted to reduce that, if you wanted to put that in the most reduced form, one way to describe it is you think of, like, what's the biggest number that you could divide out from both the 6 and the 8. Like, what's the biggest number that can be divided from both of these, and it turns out that this is really just a 2. So you're going to divide a 2 away from both of these, and then they're going to technically sort of cancel out. When you divide a 2 away from both, and the 2's are going to technically cancel. But what you're left with once you divide a 2 away from both is 3 over 4. And then you'd probably check, just really quick, even if it was just like a split second, you would check to see if you could rinse and repeat. Could you do that again? Maybe you didn't find the biggest number to divide away from both of these, but nope, this one's done because there is no number other than 1, of course, which doesn't count. There is no number that you can divide away from both 3 and 4. So 3/4 is the reduced form, the most reduced form of 6/8. Anyway, when it comes to like adding or subtracting fractions, check out these pictures, and this is a question we visited way back at the beginning of the semester, right? Section 1-2. Which set of pictures is more helpful? Remember, both of these are 1/4 plus 1/3, but which picture would make it easier to come up with like a final answer? And it turns out that it's B, really. I know it's potentially a matter of opinion, but so 1, 2, 3, 3 of these, 1, 2, 3, 4 of these that are like the same size piece. So 1/4 would be the same as 3 over what? Just like 1/3 would be the same as 1, 2, 3, 4 out of what? It's 12. So if you kind of have the same denominator, aka like the same size piece or slice, you can actually now add these together. So 3/12 plus 4/12 would equal 7/12. So you can add fractions together or subtract fractions together that have the same denominator already. That's what I just said. The denominators need to be the same. So this answer would be, since the denominators already matched, this would be 3/5, 3 over 5. Now this does not have the same denominator, so you have to multiply in order to make them the same denominator. Okay. Now all I got to do is change this 3 to a 6. I can leave the 6 alone because I can multiply by 2 to make that into a 6. Now remember the rule, okay? You can't just do that multiplication. It's not really allowed. Now, if you happen to multiply the same exact number to the numerator, then that makes it allowed. Okay, so whatever you multiply to the bottom, you got to multiply the same thing to the top, and then it's all good. You know what I mean? And so now this becomes 1/6 plus, so 3 times 2 is 6, but 2 times 2 is 4. And so 2/3 is equivalent to 4/6. And now that the denominators match, you can add them together and get 5/6. Okay, now this one, you'd have to change both the 5 and the 4. And you could change them both into 20. So I'd have to multiply by 4 and that by 5. So this would be 12/20 minus 5/20. And I think that would be like 7/20. Alright, now remember, whatever final answer you get, it should be in reduced form. So far, like 12/20 minus 5/20, that's 7/20, and 7/20 can't be reduced, so you'd be good. But if you would happen to get something like 10/20, you would have had to reduce that for your final answer. Let's see if that happens here. I don't even know. 6 and 4. Okay, now, all right, you might look at this and say to yourself, I can't really multiply to 4 to make it into a 6. At least not without using more fractions and stuff. So, yeah, no thanks. So, you're going to have to change both of these. So, I mean, if you wanted to go the route of, hey, let's just multiply 6 by 4 and the 4 by 6, kind of multiplying them by each other, you can make them both into 24. There's nothing wrong with that. I mean, I like that strategy. But you could actually, you don't got to make them both into a 24. There's actually a smaller number. There's a more least common denominator you can turn both these into, and it turns out you can turn these both into 12. So to do that, you would actually multiply by 2, top and bottom, and here you'd multiply by 3, top and bottom. Okay? So this would be 2 over 12 plus 15 over 12. So this would be 17 over 12, which doesn't reduce. Okay? Remember, when you're adding a fraction to a integer, basically, you can turn that into a fraction by just putting it like 3 over 1. 3 over 1 is the same as 3. So now it's a fraction, and so now you can make them have common denominators by multiplying by 5. Now it's going to be 15/5. So 15/5, that's 3. So 3 is equivalent to 15/5. And you can add that to 2/5 and get 17/5. Man, we're not getting any problems here that need another extra step at the end of reducing. I don't know. Might as well write this down so not to confuse you. But yeah, potentially this could be now reduced, but I guess not. Skip. Now remember, multiplying, you don't need common denominators. You can just multiply across, which in this case you could do 3 times 2 to get 6, and then 5 times 7 to get 35. So you just multiply across. Now, can this be reduced? No, it can't. Because other than 1, there's no number you can divide away from both the 6 and the 35. So let's see what happens here. Multiplying the fraction, so we multiply across. 4 times 2 is 8. 5 times 5 is 25. And again, you're done right away. No extra step of reducing. What happens here? 5 times 2 is 10. 6 times 3 is 18. Finally. This can be reduced because you can divide a 2 away from both and be left over with 5/9. Hey, same situation. You turn that into a fraction. So now you can do the 2 times 3 to get 6. Then 1 times 4 is 4. And again, hey, twice in a row. This can be reduced at the end before you're finally done. So 6 over 4 reduces to 3/2. Now, one more quick reminder about dividing. Dividing, when you're dividing by a fraction, you instead, you should rewrite it as multiplying by its reciprocal, or as I say, refliprical. So that's what dividing is. Dividing by a fraction is equivalent to multiplying by its reciprocal. So you flip and multiply. So this one you would first rewrite as 4/3. I'm trying to think of what our middle school teachers do. They say like keep, stay, flip, or I don't know. What the heck do they say? Keep, change, flip, or something. I don't know. But you keep this the same, and then you change the multiplication and you flip the second fraction only. So now this is 4 times 6, which is 24, and now 3 times 1, which is 3. And not only does this reduce, it divides cleanly. 24 divided by 3, that's just 8. I mean, if you thought of this as this reduces to 8 over 1, okay, that's great, nice job. But 8 over 1 is really just 8. Don't leave an answer as 8 over 1. That's 8. 8 is reduced. And then, of course, we're going to be doing, well, I guess I didn't have to do that right away because you could just do this first. Keep, change, and then flip. Right? Multiplying by 5 over 2 is the same as dividing by 2/5. And now, if not already, to do 4 times 5/2, you want to make this into a fraction as well, just by putting it over 1. And then 4 times 5 is 20. And then 1 times 2 is 2. And then once again, not only does this reduce, it divides cleanly. 20 divided by 2 is 10. That's probably enough. I mean, you multiply this by 1/2, 1/4 times 1/2. All right, that'll do it.